Hello students and welcome to the automobile engine class. Myself Shanko Ghosh, Assistant Professor of Automobile Engineering Department at Dr. Sudhir Chandra Sur Degree Engineering College under the GIS group. So students, before starting this module, this is a 5B module, we are already here discuss about the 5 modules. So where in the first module we covered the engine, fundamentals and the principles. Then in the second module we already covered about the constructional features, function and the working of the automobile engine component. Then on the third module we discussed about the engine cooling system. Then fourth module we covered the engine lubrication system. And then in the fifth module, section A, section A of the fifth module, we covered the fuel fed system in the petrol engine. Now here we study the section B of the fifth module, which is known on the topic of, which is known as the topic of the fuel fed system in the diesel engine. So students, before we started the class on this module, so you need to know about the outcomes and the objectives of this system. So here the objectives are students can easily understand about the fuel fed system in the diesel engine. Then they can relate about the various components which is required for the diesel fuel injection system. They can understand about the layouts of this fuel fed system in the petrol engine. They can understand about the various types of diesel fuel injection system, and they can also understand about the mechanical governor and the troubleshooting. Then and the outcomes of this, the outcome of this module, that's our student can easily understand about the difference between the fuel fed system in the diesel engine as well as the petrol engine. Students can easily identify the component that this component where is used. Is it used for the petrol engine or is it used for the diesel engine? They can easily understand or they can easily draw the layout of the make a layouts of the fuel fed system in the petrol and as well as the diesel engine. So these are the objectives, and these are the first those are the objective, and second are the outcomes of this module. So students can easily understand and got the knowledge from this module. So students, let's start the class. Here we first start with the introduction section. In case of the petrol engine, where the mixture of the air and the petrol in a proper ratio which is supplied to the engine cylinder. But in case of the diesel engine, the pure air is drawn into the engine cylinder from the atmosphere during the suction stroke and the compressed. The temperature of the compressed air varies from the 500 degrees Celsius to 600 degrees Celsius. So these temperatures are sufficient. To ignite the fuel. So the fuel is now injected into the compressed into this compressed air, with the help of a fuel pump and an injector. So so the every particles of the fluid injected into the engine cylinder and gets enough oxygen for the compressed air so it's complete combustion. So thus it can be said that during the compression of air in the engine cylinder the temperature of air goes up so that when the fuel when the fuel in the form of a fine spray comes in contact with this hot air and it ignites, and no other external means of ignition is required for this purpose. So for that reason this diesel engine is known as compressed ignition engine. So the fuel system actually developed for the diesel engine is different from that of the petrol engine. Here the fuel injector on a petrol engine is mounted in intake manifold, where the diesel injector is mounted in a swelling chamber directly in the combustion chamber. So students, in the CI engine, the compression ignition engine, the air is taken during the suction stroke and compressed to a high pressure near 228 to the 70 bar at a high temperature. That range is 520 degrees Celsius to the 720 degrees Celsius according to their compression ratio used from 12:1 to 20:1. So the high temperature of air at the end of the stroke is sufficient. The high temperature of this air at the end of the stroke is just sufficient to ignite the fuel. Fuel is injected into the cylinder at the end of the compression stroke. To the pressure of the fuel injected lies between the 100 to 200 bar. So during the process of injection, the fuel is broken into very fine droplets. The droplets vaporize, taking the heat from the hot air and form a combustible mixture and start the burning. As the burning starts, the vaporization of fuel is accelerated. As the burning starts, the vaporization of the fuel is accelerated as more heat is available. So as the compression process progressing, as the compression process is progressed, the amount of oxygen available, the amount of oxygen available for the burning, reduces, and therefore the heat release is reduces. So as the process is progresses, so that time the oxygen availability due to the burning is decreases. As it is decreases, means the combustion and the burning of availability of oxygen is decreases, the heat release is also decreases. So therefore the period in between the start of the injection and the start of the ignition is called the ignition delay. The period in between the start of injection and start of ignition, that the period is called the ignition delay, which is about to 0.001 second or 1 millisecond for a high speed engine and 0.002 second or 2 millisecond for a low speed engine. The injection period covers the 25 degree of the crankshaft rotation. So after the ignition and the temperature and pressure rise rapidly, the whole temperature of the engine is totally dependent on the delay period. The delay period is better in the engine performance. Now coming to the next slide, which is the fuel injection system. Basically, the fuel injection system is required, or it play an important role. The fuel injection is required, or it is play an important role in the CI engine or the compressed ignition engine to burn the fuel in the combustion chamber, so that as it is burned, the performance of engine, so due to the burning of this mixture, as a performance of engine like power output and economy etc is largely totally depends on the this fuel injection system. The fuel injection system has to perform importantly duty in heating and controlling the combustion process. So that's why, so here this fuel injection system take an important role to control or to operate this fuel fed system, or to produce some power in the combustion chamber of the diesel engine. Now coming to the requirement of the fuel injection system. The fuel injection system is required for to accurate the metering of the fuel which is injected per cycle. So here how much amount of fuel is injected, through the fuel injection system is totally metering these injection methods. Second is, it helps to correct the fuel injection time. So means we knew that there are the 4 strokes are available in the as a working principle of this CI engine. Those are suction, compression, expansion and the exhaust. So if here basically the introduction is injected, the proper time is just before ending of the compression stroke to just start of the expansion stroke, in between this place. But if this injection of the fuel is in a wrong timing, that's mean the timing of the end of the suction stroke, so then it is not so. Then and if the fuel injected in a wrong timing, so that's why wrong timing, so the power is not generated properly, because here the air and fuel mixture inside the combustion chamber is not burned properly. So that's why we need to control the correct of the fuel injection system. Then coming third was a full control over the rate of fuel injection. How much amount of fuel is need to inject in the proper cylinder the proper timing. So that is totally controlled by this system. Proper atomization of fuel. If we enter or introduce the fuel in the combustion chamber in a droplet form, or it is show it in a liquid form or in any bubbles form, that is not working. So we need to make it a proper atomization. That means it need to be sprayed through a nozzle in such a way, so when it is in such a way that when it comes in contact with the compressed air, then that time it got the ignite. So for that reason we need to atomize the fuel in a proper way. Next is the proper spray pattern to ensure the mixing of the air and fuel. How much amount of fuel is required for the respect to the air. So proper spray pattern you need to maintain. If we spray the fuel at an angle, so that hit to the cylinder wall, so it is not, at that time the fuel is not mixed com- properly with the compressed air which is available in the combustion chamber. So this is not a good thing. So for that reason we need to spray in a proper pattern. Then uniformly distribution of the fuel in the combustion chamber. Uniform distribution of the fuel combustion chamber, which is then another part. Then is to supply the equal quantity of the fuel in the cylinder in case of multi-cylinder engine. Is there 4-cylinder engine and we spray a huge amount of fuel in a first cylinder and less amount of fuel in the fourth cylinder. That's mean the power is not produced proper way, I mean uniformly. So that's why we need to maintain or supply the equal quantity of fuel in each of the cylinder. That it may be the single cylinder, then it may be the V cylinder, or then it may be the 4-cylinder, 6-cylinder, whatever the number of cylinder is present here, all each and every cylinders get the fuel in a proper or equal quantity. There is a no lag between the beginning and the end of the injection period. If is there any kinds of lagging of the injection period and beginning and end of the injection period, then the power is not produced in a proper way. So for that reason, the proper injection time is just before ending of the compression stroke to the just start of the expansion stroke. So in that reason, that is in that period, just in this small period, we need to beginning the injection system and ending the injection system. So these are the basic requirements of this fuel injection system. Now coming to the next slide, here we learn about the various kinds of components which takes an important role in the diesel fuel system. Those are fuel tank, fuel feed pump, injection pump, fuel filter, injector, and the governor. So these plays an important role. These are the plays an important role in placing the when we are talking about the component of the diesel fuel system. So now coming to the layout of this. Now coming to the layout of the fuel feed system of the diesel cycle. So here you can see in this picture, this is the fuel tank. This is the fuel tank. From here the fuel is supplied to the fuel filter with the help of the feed pump. So the feed pump sucks the oil from the fuel tank and then it passes to this fuel filter. When it comes from the fuel tank to fuel filter, there is a primary fuel filter is available. So the fuel is passes through the fuel filter when fuel comes from the fuel tank to the fuel filter. So here is this is a secondary filter. When it comes in the secondary filter, it is filtered and then it comes to the injector pump, and through the injector pump it is injected into the combustion chamber through the injectors. So and injector here is the, and this is the air intake way. This is the intake valve, this one is the exhaust valve, and this is the exhaust portion. Here is the combustion chamber, this is the piston showing here, piston spin, and the connecting rod is showing here. So as this is moves and power is generated, and during the power some exhaust is put, which is generated in this chamber. So this exhaust gas has been passes through the exhaust valve or through the exhaust manifold to the catalytic converter. From the catalytic converter, it is passed to the again muffler, and then it goes to the atmosphere. So these are the basics layout of the fuel fed system in the diesel engine. Now coming to the study the main components of this fuel fed system in the diesel engine. That is a fuel injection pump. An injection pump is basically a device that pumps the fuel into the cylinder of a diesel engine. Traditionally, sorry, traditionally the injection pump was driven indirectly from the crankshaft by the gears, chains, or the toothed bolt, and that also drive the camshaft, and that also drive the camshaft. It rotates at half crankshaft speed in a conventional of the 4-stroke diesel engine. Then its timing to such that the fuel is injected only the very slightly before the TDC of the cylinder's compression stroke. So it is also common for the pump belt on the gasoline engine to be driven directly from the camshaft. Directly from the camshaft. In some system, the injectors and pressures, some system, the injection pressures can be high as 620 bar, which is near to 9000, which is near to the 9000 psi. Now coming to the various, there are various types of fuel injection pump are available. Those are individual inline pump, distributor pump, and the continuous pump. So let's start with this individual inline pump. The individual pump is a pump mechanism. The individual pump is a pump mechanism with an individual fuel delivery system. So that means the each injector will be served by the plunger mechanism. It can be say the number of plunger is the same of the number of injector. So however all the plungers are placed together in one pump unit in a line position. That's why this system is called the inline injection pump. The main component of this type of pump among the others are: first is a camshaft with the number of cam according to the number of the plunger. So there are number of camshaft and the number of plungers are equal. Number of cam on the camshaft and the number of plungers are equal. Here the plunger which functions to increase the fuel pressure. So plunger is used to increase the fuel pressure. Then the fuel barrel, a small space where the fuel is readily to be sent to the injector. So the way it works, when the crankshaft basically rotates, the camshaft pump also rotates. The rotation of the camshaft will cause the cam to press against the plunger alternately. So the way it works, when the crankshaft rotates, the camshaft pump also rotates. So the rotation of the camshaft will causes the cam to press against the plunger alternately. So here is the pictures of an individual inline pump. Now coming to the another types of pump, which is known as the distributor pump. The distributor pump is a type of injection pump with smaller design. The main purpose of the distribution pump as a solution for vehicle with the limited space. The main feature of the distributor pump is the injection system. The inline types basically use the plunger for the one injector, but the distributor type uses a single plunger for all the injectors. The way it works, so this plunger will press all the fuel in each fuel barrel alternatively. The fuel barrel is placed around the pump shaft. When the pump shaft rotates, the plunger will press the fuel in the fuel barrel, so alternatively according to the ignition time. So even though it has a smaller design, the distributor pump does not have high fuel pressure. Therefore, this type is a rarely used for the high capacity diesel engine. So students, here is the picture of a distributor types of pump. Now coming to the another type of pump, which is called as a continuous pump. The continuous pump is the latest. The continuous pump is the latest type of diesel injection pump. This type is actually the most widely applied body. Continuous pump is an injection pump. The continuous pump is an injection pump that is applied to the common direct injection system. And judging from the physical, the pump has the smallest from all of the type that we discuss here. That means the individual inline pump, distributor pump and the continuous pump. So in between these three pumps, this continuous pump is the smaller pump. So the reason is the pump only has a single function, because the pump has only a single function, and its function is only to increase the fuel pressure. So it is used only to increase the fuel pressure, which is stably at a high pressure. The pressure is generated at a very high. That means it creates 30,000 to the 40,000 psi pressure. The higher pressure range is lies in between 30,000 to the 40,000 psi. So here is the pictures of the continuous pump. So students, here in the first part of this
second section of the fifth module, we discuss here about the introduction section, as well as we discuss about the layout of the fuel fed system and the study about the fuel pump which is used in the fuel fed system of the diesel engine. So in the next class we discuss about the other types of component which is used in this fuel fed system. So till then, stay at home and stay safe. Thank you so much, students.